One of the first things you've got to do is, anybody who's over 40 has got to give you a history of computing, haven't they? So this was my first computer. Ultimately secure this thing. It had no network lines, no input. Half the time I couldn't even load programs myself, so it was very secure in that respect. I went on to university where they had Honeywell mainframes. It took us less than a week to give ourselves full access to the computers. We were given a choice, either get sent down or harden up the whole of their security system, which spent the next year doing so. That was my first introduction to security in any shape or form. After that, I spent 6 years at Dell. My real introduction to security in any real form was Unix System 5. But even then, it was mostly passwords and usernames. Not much beyond that. And even the networks we had, Netware 3.1, pretty much the same thing. The security really was quite lacking. So lacking, security, what security? I've been around since '94 consulting for other people after I left Dell. Life has moved on in IT, it's developed somewhat, but there wasn't really no real great changes going on. And one of my other loves is just getting into technology with small companies all the way up to FTs, actually spreading the experience around. So you see a lot of different areas and different ways people work. Obviously, the post-it notes on the one-man bands are pretty classic. FT companies, actually not much better. The other love I have in my life is sailing around the world. And in 2010, I took my latest trip. I thought IT had settled down, so I wasn't going to miss too much while I was away. And obviously, while I was away, we had good old DevOps basically appeared on the scene, along with the cloud. Completely changed things, and it was a struggle actually to get back up to speed this time round. Most times I've been able to drop into it pretty quickly. But what's been happening over that period of time is we've gone from the good old bare metal that we used to use at Dell and sell lots of. These took months almost to deploy. They were around for years. So once you'd done security on those, it was done. We didn't have to think about it too much after that. But obviously they were inefficient, which is what we all know in the last few years. So we headed up to virtual machines after that. Virtual machines, not an awful lot different to bare metal, just makes the bare metal more efficient. But again, once they were deployed, they usually took, well, you can deploy them in minutes if you use the right templates, but they're normally around for weeks or years. So again, you're not having to think too much about security. Now we're moving into microservices or services with containers. We're getting a lot more, so there's a lot more attack vectors out there. So you've got to spend a lot more time now looking at those various attack vectors. So you're starting to be challenged, certainly on the ops side of things, how you can start looking at that. I have to wait a bit for it. Essentially, we're moving on to onto microservices now, which is Lambda. They're up for 100 milliseconds and then they die. How you're meant to be checking all those, and there's literally hundreds of these, if not thousands. So you've really got to, if you can't also automate the way you approach security and capacity on these things, you're not going to be able to keep up on these things. So we've got to approach this in a different way. As I said, this book came out in 2010 as I left the country and transformed IT somewhat. But one of the interesting things about this book is it only mentions the root secure 44 times in the entire 400, 500 pages of the book. And 10% of that is actually in the index. So they weren't even thinking about security, but we do. So how does your security and what drives your security within your organization, when do you consider it? Band-Aid at the end, much like Phil was saying. You've got the whole thing rolled out. It's a logical place to start, because how do you know what to test if it doesn't already exist and it's not already set up? Get there. This is known in the old days as dyed in the piece. When you were dyeing things back in the Middle Ages, dyes were very expensive. They looked at all different ways to reduce costs in these things. So rather than waste the dyes, what they used to do is only make the entire garment and then dip it into the dye at that point. Nice and cheap, saved on dyes, but as soon as you started getting any wear and tear, all the dye started coming off, you started seeing the colours underneath. The quality wasn't that good. You started looking pretty shabby fairly quickly. The next one, next place to consider it is your system function test. You're doing your user test, you're doing the functional test. Why not system function? Now, some people call this non-functional testing. There's a bit of a bet and wild of mine that I like to squeeze. I consider security, capacity and performance to be very much functional testing. So I'd rather describe these as system function rather than non-functional. And this one, it equates to dyed in the yarn, maybe. We're getting a good one here. Dyed in the yarn is where we've actually turned the raw material into yarns. We dye it there. This gets better coverage of the yarns, so the quality of the product to the end garment stays better looking for longer. But it's still not ideal. You still have the same issues that you had with dyed in the piece. So the last one is development stage. If you're putting all your efforts into making sure that the product you're producing is good from day one, then you don't have to worry about all the other failures down the line. You're not wasting your time with your user tests and the functional tests when it's going to fail on a security test right at the end. So all these tests need to go together, and also you need to ensure that the code coming out to start with is not going to be broken. And that was known as dyed in the wool. Some people kind of make that synonymous with stick in the mud, which is probably quite appropriate for some security people. But actually, it produces the best quality. You get the security baked in from the very beginning. So, touching a bit on what Phil was saying, we used to have dev and ops. Likewise, like Phil, I used to do probably about 30–40% devs. Now I'm probably coding about 20 days a year. Mostly ops these days, but always, because you're running ops systems, you need to keep those secure. It's your problem if somebody breaks into those. So we're adding in sec these days. And on top of that, I would also add in another part, which is both security related and operations. One of the projects I'm working on at the moment is rolling out over 200 websites into Docker containers. Now we can produce you a container with Drupal, WordPress, Joomla on it within about 4 minutes. We can take about another hour to actually migrate your application across to the new platform. It then takes 6 or 7 days for the networks team to do a 5-day SLA. Because they are so worried about their security on their F5s, they won't let anybody program them. And it's really a lack of knowledge and a lack of faith in doing this. But doing these things automated and programmatically means you're going to make less errors with doing that. And we have all the information, and we sit and watch the network guys literally cut and paste from our request ticket into their F5. And it really is nuts. So after the last incidents, which was over 12 days to make one DNS change, they finally lost the battle, and we are now going to be allowed to program their F5s. So I would say DevSecOps is probably the title. I don't think that's going to be too catchy, so I do think DevSecOps is probably going to be around, and probably people need to be reminded that security needs to go in there from the beginning. So get security in from the start. If you're doing the security continuous integration, then you don't have to worry about being audited. There's so many companies I've been to out there that they get SOX compliance, PCI compliance, and oh my God, it's a big issue. What are we going to do about it? Now, have we got there enough resources? If you're already secure at the beginning, and you know that because the code you've been coming out with has been tested before it goes into production, you don't have to worry about the auditor. Yes, they'll come in, there's certain ancillary parts of the ops team that will have to worry, but the code and how it's being applied will already be addressed. So, one of the organizations that Phil alluded to was OWASP. This started back in 2001. They literally looked at what was happening in web coding and just how bad. And the classic one was SQL injection. The number of sites I used to go through, and literally 1 = 1 on the end of it, you're in with full root access. It was just too easy. So these guys actually got together and decided we needed to do something about it. So they were focused always on improving software security out on the web applications. As Phil mentioned again, they've got their OWASP top 10, and obviously take Phil up in his offer to get that poster. Well worth it. As he said, if you go through there and make sure you understand what's going on, and it's not limited to 10 by any means, but you will be starting to address most of the major issues that are out there. As I said, the top one attack is SQL injection, and still these days there's so many sites you can just go out there and do most of the most simple SQL queries on them. These are the 10. You can read through the slides later when we send them out, but they are actually asking for 2016 security request to build the next top 10 for 2016. So that is a link on there. So if you want to go in there and add your own experiences into what's happening out in the wild, I'm sure they'll very much appreciate it. Another one that also produced a list is the Cloud Security Alliance. They had a notorious 9 in 2013. They've just come out with their own one. It's now up to the treacherous 12. So you can see there's still, a lot of people have been pushing security and trying to get it fixed, but there's still an awful lot of work out there that needs to be done from the start. Their number one concern is data breaches, and actually the data breaches primarily are coming from SQL injections. So they're pretty much hitting the same aspects. So onto ZED Attack Proxy. This was a flagship WASP project. It's their main project, and essentially it's there to try and attack all the websites. It's a white hat version, but obviously I'm sure the black hats out there are using it just as much, because this is a great tool for going to find all those things. It is an automatic web app penetration testing tool. You just point your browser at it, it will go through and spider your site. It works through proxy, and it will find all those hidden links you think nobody knows about. They're up there for the software to find. Finally. Oh. It is good for both the beginners and advanced users. It's probably the number one tool that's being used by professional pen testers. But it is a very good front end that's simplified enough that anybody gets value from it literally from within the first 10-15 minutes. You will go in there, put your own site in there, and within 15 minutes you will start getting back vulnerabilities in your site, and it's very quick without having to have an awful lot of knowledge behind it. It's had very wide support from all sectors of industry. It was a Google Summer of Code project to improve it a great deal, and also the lead developer, a guy called Simon, he was actually employed by Mozilla, so they've been pushing it as well. So it's getting a lot of development and being kept up to date. So the features, one of the things, probably not a feature for some of you, it requires Java. It is open source, so you can go up to GitHub, look at how they've coded it, what they've done for it, make your own changes to it if you want to fork the code. But it is fully open, so you can go in there and try it out. It incorporates other tools. Selenium is a web driver, so essentially you put scripts into Selenium and you actually drive your websites. It's a classic one for just testing user functionality in your websites. Because you're proxying for a ZED Attack Proxy, then you can actually use Selenium to automatically regression test your sites. I'll wait for that one to come up. It will come up, I'm sure. The other thing it has is it's fully extensible in much the same way as a lot of these things. They've got a marketplace now, so you can actually write your own add-ons onto the thing. They're removing some of the functionality out of the core to try and keep it light. So the port scanner now used to be part of the standard product. If you don't need port scanning, because you only open up 1-2 ports, 443 maybe, then you don't need the rest of the port scanning. So that's a plug-on these days. But you can, if you've got the need to, you can write your own plugins for any specific testing. It essentially has all that you need for penetration testing. But like all tools, it's not a silver bullet. There are lots of different tools that the hackers are using, and you should be doing the same. Why this is one of the key ones. There's others out there. Metasploitable is one of the classics that a lot of people know about. You should be using those tools and any other tools you can think of, because the hackers are doing that for you. Delay here. As I said, you can use it as a point and click tool. You can literally go in there, and I'll show you on the demonstration shortly. You can put in a website, click the button, and watch it go and get all the pages on the site first, and try some of the attacks, the basic attacks when it. Which means it's very good. As I say, you can learn this within 15-20 minutes, and you can get value out of it once you've got it loaded up. But it's also very useful for developers' quality assurance. They can make sure that their code is correct. If they've written something, they know about Sql Injection, of course they do. But have they remembered to actually quote that statement this time? They can put this code in as soon as they submit code in a normal continuous deployment pipeline. That code will go into Jenkins. Jenkins will fire up ZED Attack Proxy, and then you can come back and say, yes, it's worked, or no, you've forgotten to escape that statement. So it's also useful for learning about security. It doesn't just tell you yes or no, it actually gives you full details about what's gone wrong, how the attack was actually formed, and also further information about where to go and look for providing better coding around these the tools. So it's great, as well as being for professionals, it's great for people learning the system to start with. As I said, a lot of professional pen testers are now using this. not as one of their only ones. And why we talk about being automatic, you can't do all of this automatically. You do actually have to start getting your hands dirty. There's things like you need a log on to your site. You can just get it to brute force that log on, but it's a lot quicker if you just go in there, do some manual browsing of the site. It will pick up that browsing because it's using session cookies, it knows about session cookies, it's proxying all the content that's being sent there. So it will start picking up your site a lot quicker. And then when you do the attack, obviously you've got a lot more comprehensive attack from an end user point of view. Also, it's going through automatically clicking on links. So if you don't actually add the user credentials, which you normally have to do manually, it will click on the log out link and then it won't be able to test the rest of the site. So it needs to be able to log back in again a second time to go and browse the rest of the sites. That feeds into doing the automation. So once you've done some of this stuff, you can then start automating. And they've got both a full REST API, which you can use to program other tools to run ZAP, and you've also got ZED scripts in there. ZED scripts essentially take what you're doing with ZAP, and they will record those functions that you're using. And it's the way they normally ask for you. If you've got any vulnerabilities you would want to question with them, they ask you for a ZED script, so they can actually completely recreate what you were doing rather than having to ask you to document all these steps. Continuous integration, we'll be going on to more, but essentially what we can do is proxy regression tests. Regression tests is where you just have a standard set of tests, and every time you put your code in, it runs through those standard tests, so you know your content has not been affected by the latest change. And because that's going through the proxying, we can automate that very quickly. It also has a plugin within Jenkins. So you actually run this from Jenkins. It fires off ZAP from within Jenkins and can run all the functions of ZAP. So you can get the same scanning, the spidering of the sites, the reports, and all the rest of it that comes out of that plugin. As I said before, it works through a proxy, so what you do is just go into your browser, you set it for normally localhost and 8080 as the standard, and then it's watching all the traffic that's going through that proxy. It has active and passive scan. So a passive scan is where it just goes through and spiders the site. So it will look for all the links on your site and just goes through and finds those links and adds them to the list of known pages. The active one is where it will actually start trying to attack those links. So if you've got logon pages, you've got forms, even if they're hidden forms, they're not hidden to a proxy, they can find them quite easily, and it will go through and attack the sites very quickly. You also don't need to use it through the UI at all. You can use it in headless mode, which is what the Jenkins plugin does. That goes through and just runs it from the API. So if you've got your favorite tools like Apache Ant or something that's running your Java app, then you can then use the same tools to use the API and get the content out. Again, as Phil alluded to, there are penetration testing sites. These help you to get up to speed on some of the security flaws that you see. The obvious ones are command execution and injection, but there's many more. One of the major ones is Damn Vulnerable Web App, which I love the name. Some people who don't like the swearing actually said deliberately, but it's actually known as Damn Vulnerable. It's literally got a site, it's got different levels of security that it puts on there. You go and choose your level of security, and then start your testing in there and to see how good the attacks are. It's a great way to learn what the attacks are and how vulnerable some of these sites are. The other one is Bodge IT. This is actually written by Simon, the lead developer on ZAP. And it's another version of a vulnerable web app. It's got all the holes and security flaws in there for you to go and find. So you just run these up, point at ZAP at it, and see the different scenarios. You can then go and look at the code and see how you can fix it. So it's a great learning tool to see how to improve some of the errors that are happening there. Another one, as I said, mentioned earlier, was Metasploitable. This one hasn't got a Docker container for it at the moment. The other two do have got Docker containers, and I highly recommend you go and run those. They're a bit of a faff to set up otherwise. Docker container, you literally download, hit the run button, and they're off. So a lot easier. One of the things about testing is get permission. You are attacking a website. If it's your own and it's internal, it's not a problem. If it's your own and there's somebody in the support guy and he gets called out at 3 o'clock in the morning because you're attacking the site and he's coming in for a DDoS, he's not going to be too happy, and she's probably going to be even less so. So make sure you let people know or get permission. And you'll probably invalidate your tests anyway. There is a lot of tools out there, from DNS checking. We used to run something on HA Proxy that just said if you made too many requests in a certain number of seconds, we just cut you off. So if you don't let people know, you'll probably invalidate your tests anyway. Or maybe that's what you want to test, the fact that you are being spotted and caught out. But as I say, let them know. And the other one is the AWS. They do have a request form. The link is here, and it will finally come up. They are very hot on blocking malicious traffic or anything they consider it. So if you want to test your website and your web application on the cloud, then fill in that form. It gives you full details on that web link there. And they will give you a certain period of time, and you can do what you like with it. So they're very much up on security side of things and getting it tested. So now demo time. This is going to be fun because I've now got to change over screens. So we're going to see how well this works. If I can find the mouse at all. Right, as I said, ZAP is a jar file, so you literally just download the application in one tar file and unpack it, and then just run zap.sh. Probably can't see that. Let me just increase that. Ooh, and I can't see that either. And this is where it starts running on the other screen. Right, one of the things it has, if you can see that on there, the first thing it will do is come up and ask you about sessions. Sessions are there to record everything you've done. So when you save that session, you can go back to it and check all the different vulnerabilities that are on there. You can run without it, so as soon as you close down the UI, you've lost all that information. But otherwise, it will save all that information into the session file for you, and you can open that up at a later time. I think I'm probably going to curtail this fairly quickly because I can't see too well. Right, as you see there, we've got the attack browser here. You can literally just type in whichever one you want and hit attack, and off it will go. It will go and spider the site for you, and it will then follow any links on that side. So one of the things you have to note is it starts up in the far corner there in standard mode. In standard mode, it can do dangerous things. They left it in standard mode because they wanted people to know that it would actually work out the box. It's one of those things, it's kind of unsafe, but you need to know about it. So if you just want to attack your own sites in your own scope, then you need to start using protected mode. And it has a concept of both a scope and a context. So when you go browsing on here, you'll literally, I'm not going to show you because it's too difficult on the screen, but you can go out and do this for yourselves. It will come up and find the site. So all you have to do is set the proxy browser, the proxy setting on your browser to 127 local host, and then 8080. And as soon as you go into here, Zap is watching that, and you'll start seeing all the pages it's gone through appearing on the site. So what you then do is add those into the new context. So you find your page, add that page into the context, and then say that's the defined scope. After that point, it will only follow items in that scope. So typically you have JS scripts that are coming from Google or elsewhere. It will not follow those anymore. So you will not be bugging Google with the same attacks that you're doing on your own website. So very, very important to understand the modes that it's working in, and also the scopes that you're working to. As I mentioned before, what we can do is regression tests. Now this is where you get 2 for 1 effectively, because you should be doing these, or if you're not, then start considering about it. Effectively what you can do is get, as I say, something like Apache Ant or any other web driver, create your scripts and use Selenium to actually drive your website automatically. So you're going through testing the functionality automatically. You can get through an awful lot of testing there. That goes off and tests your web app at the end. But what we can do then is actually do a security regression test at the same time, because what we'll do is drive Selenium through Zap. So instead of going straight to your app, you're going through Zap. Zap is doing all your security testing for you. So at the same time you're doing your regression tests, you can also be doing the security tests at the same time. So you get 2 for 1, and it shouldn't cost an awful lot more. On top of that, we can also drive directly from the API. So if you're not using Selenium, you like to do things directly, then that's also possible with the full API there. As I mentioned, it's got a Jenkins plugin, and that allows all the functions of Zap to be run via the API from Jenkins. So you can set up your Jenkins scripts in the normal fashion, and then just run Zap automatically from those. So it runs the scans, it will save reports in all the Zap formats, and it will also load and save the sessions, so you can go and revisit those sessions later if there is something of particular interest that you want to get to. Around Zap, there's various tools that have been built up, and one of the ones that's out there now is actually a testing and automation framework. This uses Zap and a few other items in security. SSLIs, which goes and examines your SSL certs, and security. Nessus, which is another vulnerability scanning. As I said, ZAP isn't a magic bullet. You need to use other tools. And they actually use Selenium to drive all this. And it was actually written by Stephen DeVeers, who was one of the co-founders of OWASP and went on to work on this product and several others of his own. Again, it's open source, so you can get in there and have a look at the code and see how it's driven. Co-founder, as I said, and this time I will try and switch to video, which will be fun. On the basis I didn't. I didn't dare try and do this. So what you do is your normal continuous deployment pipeline. You make changes to your code as you go along. Trying to make it unsafe by the looks of it here. And then we would go in and book that into GitHub. So we're then submitting our code, and GitHub then would use the webhooks, and Jenkins will pick up those webhooks and will start the build process. It actually builds two sets. One is your application that it's building, and it's also building the testing framework that's put together with the language for the BDD. And then that runs, as I said, by ZAP. You can see there, this is the Selenium that's now driving the website, going through and testing all the different function parts of your site. And it starts bringing up all the different scans, an awful lot of them. And at the end of it, you will start getting full output from the system. Again, as per ZAP, it starts bringing out all the different errors, and we'll start reporting on them and showing you exact errors, what's happening, why it's happening. Another part on there is the fact, because it's being run through Jenkins, and Jenkins has got the code from GitHub, then it can actually take you straight to the actual code that has caused that particular problem. So you can go straight back to where the issue is. And this very much shortens the debugging time within your system. It also goes through and gives you very detailed reports, what's happened, why it's happened, and even quite a lot about how to actually fix the problems on there. As you can see there, fully detailed all the way through, and that's just showing that Bob can see Alice's information. And the last part. Okay, the links are up there. This should already be live up there for you. So it's got all the links that you've seen tonight. The top one is the actual slideshow, but you can get through all the different parts and download all those. Some more ones there, the ancillary ones. And that's it.